Morning, everybody. Today we're talking about sequences and rational and irrational numbers. So what we're going to start with is sequences. This is another thing that we haven't learned before, but basically we're just describing the pattern. So if we describe the pattern and then find the seventh term, we got to look at what we have first. The first one, we have arithmetic sequences, so it's just going to be going up by a certain amount every time. So we go from -7 to -3. We're going up by -4, or we're going up by 4. Then -3 to 1. We're still going up by 4. Then 1 to 5. We're still going up by 4. So our pattern then is adding 4 to every one. So if we're trying to find the seventh term, we know we have -7, -3, 1, 5, that's 4. 5 plus 4 is 9. That's 5. 6 would be 9 plus 4, which is 13. And 7 would be 13 plus 4, which is 17. So our seventh term then is 17. Here it looks like we're going down by 4, so we're subtracting 4, subtracting 4, and subtracting 4. So that means that after our next term is going to be 5 minus 4, which is 1, then 1 minus 4, which is -3, and -3 minus 4, which is -7. So that's 1, 2, 3, 4, 5, 6, 7. This is our seventh term, -7. So now we are given a formula that we need to find the first two terms and then the term named in the problem. So our formula then is a sub n equals -10n minus 24. So if we are looking for the first two terms, we can put in first 1 for a or n. So we're going to have a sub 1 equals -10 times 1 minus 24. This will give us our first term. So -10 minus 1 gives us -10 minus 24, which would give us -34. Our first term is -34. Then if we want to find the second term, we're going to put in a sub 2. So -10 times 2 minus 24. -10 times 2 is -20 minus 24. That will give us -44. So those are the first two terms. It looks like it's going down by 10 each time. Now we're going to find what a sub 21 is, or the 21st term. So we're going to have -10 to the 21st, or times 21, minus 24. So -10 times 21, that would give us -2100 minus 24, which would give us -2124. So the 21st term is -2124. Over on this one, we need to find a sub 1 first. So we're going to put 1 in for n. So we get 31 plus 4 times 1. So then our answer comes out to be 31 plus 4. So our first term is going to be 35. Then we're looking for our second term. So a sub 2 So 31 plus 4 times 2 . 31 plus 4 times 2 is 31 plus 8. So our next term is going to be 39. And finally, we're going to find the 12th term. So a sub 12 equals 31 plus 4 times 12. So 4 times 12 is 48. And 31 plus 48 gives us 79. So our 12th term is going to be 79. Now we're going into geometric sequences. Geometric sequences aren't just adding, it's going to be adding or subtracting, it's going to be multiplying or dividing. So what we have here is -3, -6, -12, -24. It looks like it's going down by, it's definitely going down because we're getting smaller, but it looks like we're multiplying each of these numbers by 2. So -3 times 2 is -6. -6 times 2 is -12. -12 times 2 is -24. So then -24 times 2 would be -48. -48 times 2 would be -96. And then our last term, our 7th term, is going to be -96 times 2, which equals -192. So our 7th term then is -192. Here we need to figure out what we're multiplying or dividing by. It's going down, so and that's positive, so it looks like we're dividing. So even if you don't know 216 divided by 72 easily, you can look at 24 divided by 8, which gives us 3. So we're dividing 3 each time. And dividing 3. So what we're going to do to find our next term is 8 divided by 3, which gives us 2.7. Excuse me. Then 2.7 divided by 3, which gives us 0.9. And lastly, 0.9 divided by 3, which gives us 0.3. Alright, now we are going to again find our first 2 terms and then our 8th term. So we're going to have a sub 1 to give us our first term. So that's going to equal 2 times 3, and then a 1 minus 1 up here. So 1 minus 1 is 0. Anything to the 0 power is 1. So we're going to have 2 times 1, which equals 2. Our first term is 2. Our second term then, we have a sub 2. That's going to equal 2 times 3, and our parentheses our exponents then is 2 minus 1. So we're going to have 2 times 3 to the 1. 3 to the 1 is just 3, so 2 times 3 is 6. So our second term is 6. Then our 8th term, we're going to have a sub 8 equals 2 times 3, and our exponent is going to be 8 minus 1, so we're going to have 2 times 3 to the 7th power. So 3 to the 7th power then is 2,187 times 2, which gives us 4,374. So our 8th term is going to be 4,374. Alright, our next problem, we're going to find the first term, so a sub 1 equals negative 4 times 2 and 1 minus 1. So what we're going to have then is negative 4 times 2 to the 0 equals something. Anything to the 0 is 1, so negative 4 times 1 is negative 4. Our first term is negative 4. Then we're going to have a sub 2 so we have negative 4 times 2, exponent is 2 minus 1, so negative 4 times 2 to the 1, anything times 1 is that same number, so 2 times negative 4 is negative 8. And finally we are going to have a to the 8th power, or sub 8 I mean. So we're going to have negative 4 times 2 to the 8 minus 1. So negative 4 times 2 to the 7th. And 2 to the 7th is going to give us 128. So it will be negative 4 times 128, which gives us negative 512. Negative 512 is the 8th term in that one. So here is just a graph showing you the difference between arithmetic and geometric sequences. Arithmetic, we have a line that goes straight up through our points. Geometric then is a little bit different. It's not going straight up, it's kind of curving upwards. Alright, so our second part of this lesson is rational and irrational numbers. So first off, we're going to start by reminding you guys about what rational and irrational numbers are. We start with real numbers. Real numbers are all the numbers we deal with until calculus. So every single number that we deal with in this class is going to be a real number. Rational numbers are going to be integers, so every number, whole numbers, so everything from 0 and up, and every fraction or decimal. So rational numbers are every fraction or decimal, like negative 1/4, or 1/2, or 0.5, or 2 2/3, or negative 2.34. Irrational numbers are numbers that do not end or repeat, or they're non-perfect squares. So these numbers, they would not end. So if we did the square root of 3, we would get 1.732 on and on and on. 1.732. Just like with all the rest of these, they would just keep going on and on. They are non-perfect squares. So what we're going to do is simplify the square root here. The square root of 36, what is the perfect square to get 36? Well, it's 6, so 6 here. Here the square root of 64 is 8, but we have this negative out front, so we need to make it a negative 8. Then the square root of 81, which is 9. Now we need to find the square root of the top and the bottom. The square root of 4 is 2, and the square root of the bottom is 5. Square root of 4 is 2, square root of 25 is 5. Alright, we need to figure out which two consecutive integers is the square root. Well, we know that our perfect square below this is going to be 36. And we know the perfect square above it is going to be 49. So the square root of 36 then is 6, and the square root of 49 is 7. So the square root of 41 is somewhere between 6 and 7. Here we know that the perfect square below 136 is 121. And we know that the one above it is 144. The square root of 121 is 11, and the square root of 144 is 12. So it's somewhere between 11 and 12. Here we know that the square root below it is 16, and we know the square root above it is 25. So the square root of 16 is 4, the square root of 25 is 5. But we do have a negative sign out, so we can put a negative in front of both of those. So it's between negative 4 and negative 5. Alright, our last problem's on here. We are comparing real numbers, so we need to figure out which one is less than or greater than. We need to figure out which one is greater than. So the square root of 8, if we put that into our calculator, we get 2.28, or 82, sorry, 2.82, and on and on and on. Which one is bigger, 2.82 or 4? Well, it's 4, so I'm going to say 4 is bigger. Here we have to find the square root of 10, and the square root of 10 is 3.16, on and on and on. So what's bigger, 3 or 3.16? Well, 3.16 is bigger. So we know the square root of 10 is the biggest there. Here we are going to label the numbers as real, rational, irrational, whole, or an integer. So we're going to create a table. We're going to have negative, or the absolute value of, not the absolute value, the square root of 3, 5.5, negative square root of 16 and 0. So if we create our table here, on the top we're going to have real, rational, irrational, whole, and integer. Now we know all of these are real because they're all numbers that we deal with in calculus. Now rational numbers are all decimals or fractions. So we have a decimal here, so we know that this is rational. We know that the square root of 16 is 4, but then we have a negative, so it's a negative 4. We know that this is rational, and we know that 0 is rational, which leaves the square root of 3. That's not a perfect square. 3 is not a perfect square, so it must mean it's irrational. And it can be either rational or irrational. It cannot be both. Whole numbers, looks like we only have 1, because whole numbers cannot go below 0. So we can't have negative 4, and we can't have 5.5 because that is a decimal. Integers, we know we have the negative 4 and the 0. We can't have a decimal as an integer. Last one, we need to order them from least to greatest. So this first one, 0.47 repeating, is like 0.4777777 and on. Then the next one is 0.474 repeating. So 0.474, 474, 474. We know that the third one is 0.47 repeating. And we know the last one is something we're going to need to put into our calculator. The square root of 0.23 is 0.47 or 0.47953. On. So what our least number is then is going to have to be the 0.4744 because it's got this 4 here. Our least then is 0.474 repeating. Our next least has got to be this 4747 because we have all 7s here and all 9s here. So 0.47 repeating. This is 1, this is 2. Third one, we're looking at the first 3.477 or 0.479. The next one has to be 0.47 repeating, which makes our greatest one the square root of 0.23. So this is the third least and this is the fourth least or the greatest.